Welcome to Unit 4, Lesson 7 on exponential growth. At this point, you should have had a look at a handout on an exponential graph and have an idea of what an exponential graph looks like. So exponential growth is used to represent a situation where there is a percentage of growth over a certain period of time. Examples are population growth. You read in the newspapers how a population is growing by 2.5%. Price increases. You might hear somewhere that the cost of fuel has increased by 5.8% over the last 10 years. And the third one that most of you will encounter in your life is compound interest, which is the way interest is calculated when you borrow money or invest money. So basically the equation for exponential growth has a pattern. And the pattern is P of n equals a bracket 1 plus r to the exponent n, where a is the initial value, so it's what your population is to start with, what the price was to start with, the amount of money you invested or borrowed, whatever you start with initially is your a number. R is the rate of growth, and it could be a fraction or a decimal. So when you talk about growth as being an increase of 2.5%, you would have to change your percent to a decimal. N is the number of growth periods, so that's how long, what time span it's growing for. So if we take a look at an example, the price of new homes increases 3% each year. The value of a $125,000 new home can be modeled by the equation P of n equals 125,000 times 1 plus 0.03 to the n, where P is the price and n is the number of years in the future. So a couple of things to note before we sketch. If we look back at our equation pattern, we know a few things about this situation. The number at the front is the initial value. So that means when they bought the house, it was worth $125,000. The 0.03 is in our word problem. It's the 3% increase each year as a decimal. And the n is the time frame that we don't know yet. So we'll look at that as a number of years in the future. If I want to graph it based on all your graphs you did before, you should know that the exponential graph will always have this shape. Really the only question is, where is that shape starting? And the equation tells us the initial value is $125,000. So it's starting at $125,000. So we know the value of the house, and we know that this axis would be over time. So we just do a rough sketch so we know what it looks like. What will the new home cost 8 years from now? This is where we figure out our n value. The question's talking about 8 years from now. 8 is our n value. So we plug it into our equation. The value of the house at 8 is 125,000 times 1 plus 0.03 to the exponent n. And then this is where you get your calculator out and calculate. And this is where I go get my calculator off my desk and figure out the answer. So my calculator, there we go. So if you're working along with me, 125,000 times 1.03 to the exponent 8 would give me, oh, and I forgot to take out my n and put in my 8. There we go. Would give me $158,346.26. So therefore, in 8 years, the house is worth $158,346.26. What will it cost 12 years from now? Well, we'll put in our 12. 125,000 times 1.03 exponent 2. 1 plus 0.03 is 1.03. And we get our calculator going again, 125,000 times 1.03 to the exponent 12. Means 178,220.11. Therefore, in 12 years, the house is worth $178,220.11. Perfect. Easy peasy. Let's look at one more example together. Population of a certain bacteria doubles every hour. The population can be modeled by the equation P of n equals 5 times 2 to the exponent n. What is the initial population? So I look at my equation. The number in front of the brackets is always the initial amount. So the initial population is 5 bacteria. So how many bacteria will be present after 4 hours? We replace n with 4. So I have P of 4 equals 5 times 2 to the 4, which can be 5 times 2 to the 4 is 16. Remember bed mass, do exponents first. So 5 times 16 times 16 would be 80. So therefore, 80 bacteria are present after 4 hours. And last one, about how long will it take to reach 10,000 bacteria? So this one's a little bit different. This time it's telling me how many bacteria I have. It's telling me the answer, and I have to figure out the time it takes to get there. So it's telling me I know that I have 5 times 2 to the n, and the answer is going to be 10,000. So I want to solve my equation for n, which means I want to get it by itself. In order to get a letter by itself, you move the numbers away from it by doing the opposite operation. So instead of multiplying by 5, I'm going to divide by 5. So 2 to the n equals 10,000 divided by 5, which would be 2,000. So the problem with an exponential equation is that I can't separate the 2 from the n. So when we have an exponential equation, the only way we have to solve it is basically we're going to guess and check our way to find the right exponent. So when I put 2 to the exponent, I will get the answer 2,000. So we'll make a little note of that. So we need to use organized, guess, and check. That means I'm going to make a little table. I'm going to choose or guess numbers for n, and I'm going to do 2 to the exponent n until I get an answer close to 2,000 in this case. So we're probably going to have to start with a pretty big number. So I'm just going to get my calculator out, and I'm going to go 2 to the exponent 10. And so I use 10. So 2 to the exponent 10 on my calculator is 1,024. But I'm looking for 2,000. So I'm going to try a bigger number. 2 to the exponent 20. Way too big. Now I've got 1,000,000. So I'm going to look between 10 and 20, like 15. 2 to the exponent 15. Still way too big. So I'm going to keep working my way down. Maybe 11. 2 to the exponent 11. Oh, 2,048. So I could try to work my way down even smaller. Try 10 and a half. 2 to the exponent 10.5. And I've got 1,448.2. I could try 10.8. 2 to the exponent 10.8. It's 1,782.9. And I could try 10.9. We won't try anything smaller than 1 decimal. Exponent 10.9. And I've got 1,910.9. So I look at my answers and see how close I've gotten. I've gotten 2,048, and I've gotten 1,910. 11 is probably closer because it's only 48 more. 1,910, we're still 80 off. So we would say that after about 11, what was the time in this question? Hours. So therefore, after 11 hours, we would reach 2,000 bacteria. So the point being that to solve when your letters in your exponent, you need to make a table and guess and check your numbers for your exponent until you get close to the answer that's in the question. All right, one more quick example. The value of an investment after n years can be modeled by the equation b of n equals 1,500 times 1 plus 0.035 to the n. Explain what the 1,500 and the 0.3035 in the equation represents. Okay, so that number in front of the bracket is always the initial value. So the 1,500 is the initial value of the investment, or what they started with. So what they started with or invested. The 0.035 is the growth as a decimal. So when I change it back to a percent, I would multiply it by 100 and get 3.5%. If I want to calculate the value after 4 years, I take out my n and I put 4. Calculate the value after 4 years. I would take out my n and put 4. So 1,500 is 1.035 to the 4. So 1,500, got my calculator going. Is 1.035 to the exponent 4, which leaves the investment worth. Therefore, after 4 years, it's worth $1,721.28. Last one. Calculate the value of investment at the end of 15 years. So the value at 15 years would be 1,500 times 1.035 exponent 15. Therefore, there we go. There is exponential growth. The initial amount times 1 plus the growth rate plus to your exponent, which is your time it's been invested for and time it's there. All right.